Chapter 7, Lesson 3, we're going to take a look at logarithms and logarithmic functions. So being able to evaluate logarithmic expressions. So logarithm written here has log in it. Okay? It has a base value with another number. Okay? It's read as y equals log base b of x. Okay? So it's just another way we can rewrite exponents. Okay, so this is what we're looking at here. Okay, transformed into here. So the base, it stays the base in the exponent. X is the answer, and y is the exponent. Okay, and so this first two examples here, first two parts, we're just rewriting them, going from logarithmic form here to exponential form. So again, the base, log base 2 is the base of in the exponential form as well. The exponent here is the 3. So 2 to the third power equals 8. That's all we're doing, just rewriting it. Okay? So in letter B, 4 is my base, exponent is the 2, and 16. Letter C, base is 3, exponent 4, answers 81. It doesn't matter what the numbers are, you're just putting those values in those specific spots. So base of 3, exponent 6, 729. Log of 4, base of 4, exponent negative 4, answer 1 over 256. So that negative gives me that fraction, right? And then base 10 of negative 2 equals 1 over 100. Okay. So that's writing it from log form into exponential form. And then we can go in reverse. We can go from exponential form into logarithmic form. So again, we're taking log. The base is 15. Answer 337.5 equals exponent. So 4 to the third equals 64. Log base 4. Answer is 64 equals exponent 3. Okay, again, we're just rewriting it, changing the way it looks. So log base 5 of 125 equals 3. Log base 4 of 2 equals 1/2. Log 125 of 5 equals 1/3. And log 27 3 equals 1/3. Okay? So that's just the rewriting portion here. Now, how can we solve these, evaluate these expressions? So we're just evaluating by hand here. So again, I'm thinking about this. If I rewrite it, it's 3 to what power equals 81. So we're just going to keep multiplying. 3 times 3, well, that's 9. Times 3, well, that's 81. I'm sorry, 27. 27 times another 3, 27 times 3, that gives me 81. So how many 3's am I looking at? 4 of them, so x in this case equals 4. So you know what number you're multiplying, just how many times do I need to multiply it to get to that value, in this case 81. So letter B, we write it exponentially, so 3 to what power equals 243. Now we already did part of the work, we're already up. 4 of them is 81, right? If I multiply by another 3, 81 times 3 gives me that 241, or 243, sorry. So if I have 4 times another 3, that gives me x being to the 5th power. Okay? So again, as you start multiplying these, you'll remember these perfect cubes, squares, okay? It'll become a little bit easier for you as you work through. So 8 to the what power equals 512. So 8 times 8, well that's 64 times 8, and that's going to give me my 512. So 8x to the third power, or 8 to the third power, so x is 3. So here we can get a little bit harder. So 3 to what power equals 1/9. Now, how do I get the number to the bottom? Well, it needs to be negative. Okay? So whatever that value is needs to be negative. And 3 squared gives me 9. So x is going to be a negative 2. So the negative is going to move it to the bottom. So the square is going to give me the 9. Okay? So same idea here. 4 to what power is 1 over 64. Again, the negative is going to move it to the bottom, and then 4 times 4 is 16, times another 4, and that gives me 64, so x is to the negative 3. And the last one here, if I'm going here, 9 to what power equals 3. So here you see that number got smaller. The only way that number to get smaller is to take that square root, okay, or take a root of it. In this case, the square root of 9 is 3. Well, again, exponent square root, right? Square root of 9 written as an exponent is 9 to the first power and the square root. So 9 to the 1/2. So in this case, x equals 1/2. Okay. So that is your logarithms and logarithmic functions. So short notes today.